Greetings, fellow Meccas. Today, we'll be looking at a welfare problem. The problem. Two workers share an office. Bill likes to smoke cigars and has a daily demand curve for cigars given by Q equal 28 minus P. He can buy cigars for $4 each. His office mate, Jim, suffers harm and annoyance from the cigar smoke with the marginal cost of 2Q. Part A. If there are no prohibitions on smoking in the office, how many cigars per day would Bill smoke? Part B. What is the allocatively efficient number of cigars for Bill to smoke each day? Part C. Illustrate in a graph and calculate the difference in welfare between Part A and Part B. Part D. Is the harm caused to Jim equal to 0 at the efficient cigar level? Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's work on it together. So part A. If there are no prohibitions on smoking in the office, how many cigars per day would Bill smoke? So to solve this, we need to find the competitively efficient equilibrium essentially. So we need to set Bill's marginal private benefit equal to the marginal private costs for Bill. So what is Bill's marginal private benefit? Well, that's his demand for cigars, which is given at 28 minus P. And this is going to be equal to his marginal private cost. And Bill can buy the cigars for $4 each. So now we solve for... Oh, wait. Now we can solve for QC. All I did with this demand function Q is equal to 28 minus P. I just swapped pricing Q, which you can do. So we get QC, the competitive equilibrium, is going to be equal to 24. I just subtracted 4 on both sides and added Q on both sides to get QC is equal to 24. And this gives us a price at the competitive level for Bill of 4. Which makes sense because that's how much the cigars cost them. That's part A. Now, part B. What is the allocatively efficient number of cigars for Bill to smoke each day? Well, that is going to be the efficient equilibrium, or marginal social cost equal to marginal private benefit. And our marginal social cost is equal to, marginal social cost is going to be equal to our marginal private cost plus our marginal external cost. We are given a marginal private cost equal to 4. And then our marginal external cost is going to be Jim's marginal cost of 2Q. So this is 2Q. And this is going to be marginal social costs. So we get marginal social cost of 4 plus 2Q is equal to a marginal private benefit of 28 minus Q. We can subtract 4 on both sides and add Q to both sides to get 3Q is equal to 24. divided by 3. And we get QE is going to be equal to 8. We can plug in this QE equal to 8 into either MSC or MPB. We can just plug it into MPB, so we get PE is 28 minus 8, so PE is going to be equal to 20. So the efficient equilibrium of the quantity is 8 and the price is 20. That's the answer for part B. Now part C, illustrate a graph and calculate the difference in welfare between part A and part B. So we can draw the graph first. Then we can calculate the change in welfare. We have our x-axis to be a quantity, our y-axis to be price. Our marginal social cost is positive upward sloping. And starts at a 4. Our marginal private benefit is downward sloping. And that starts at 28. A marginal private cost is constant 4. So horizontal line. So this is our marginal private benefit. So where marginal private benefit and marginal private cost intersect, this will be our competitive equilibrium, QC, and that's PE or PC at 4. And where the marginal social cost and marginal private benefit intersect, this would be a efficient equilibrium. So this is QE, and this is PE, which is equal to 20. And from QC up, if you draw a vertical line straight up, I just drew a dotted line straight up to marginal social cost. This triangle right here is going to be a change in welfare. So we'll just label this as CEB. So this is this triangle. The triangle is the change in welfare. So this QC is, this is 8 for this, and this is going to be equal to 24. So to calculate the change in welfare, well, you just finding the area of that triangle. So the area of EBC is the change in welfare, and this is 1/2 the base. The base is 24 minus 8. I mean, that's the height. So we do 1/2 height times base, so base times height. Let's do the height first. 24 minus 8 is 16. And then to find the base, well, we need to find QC at the marginal. So we need to find the marginal social cost at 24. So we can use 4 plus 2 times 24 to find the point B. And we get 48. We get 48. Yeah, 48 plus 4, which is 52. So the base is 52 minus 24. Oh wait, that's the price. So 52 minus 4, which is equal to 48. Yep. So the price at B is 52, but then to find the base is 52 minus 4, which is equal to 48. So then the change in welfare, which this is going to be equal to 384. So that's our change in welfare, all the area of the triangle. That's part C. And now part D is the harm caused to Jim equal to 0 at the efficient cigar level. Well, the marginal external cost to Jim is 2Q at the quantity, at the competitive equilibrium. The quantity makes his marginal external costs equal to 48. And this is just 2 times 24. And at the quantity efficient equilibrium, his marginal external cost is equal to 16, and this is 2 times 8. So we can see from the competitive to the efficient equilibrium, his marginal external cost decrease by 32, and therefore the harm is reduced, but not at 0 at efficient cigar level. So even at the efficient cigar level, Jim is still experiencing harm and ignorance. And that is the solution to this problem. If this video helped, please consider subscribing and liking this